Good day, everyone. You are welcome to my channel. If you are joining us for the first time, this is Ojibra Academy YouTube channel. And in today's episode, we'll be talking about one important part of chemistry, which we all know as electrochemistry. Electrochemistry. In this part of chemistry, we'll be looking at how chemical reactions relate with current, production of current production. Yeah, you can put it as current production. How these two things relate is what we'll be dealing with in electrochemistry. And as a matter of fact, electrochemistry itself is a subdiscipline of chemistry that deals with the study of electrical energy and chemical changes. Therefore, chemical reactions that involves input or generation of electrical current are called electrochemical reactions. So to start with, electrochemistry, it has two parts. It can be subdivided into two parts, which is the first part is the part we all know as electrolysis, and the second part, which is electrochemical. Now, so we're going to take it one after the other. So basically, in this video, we'll be explaining electrolysis. So in the next video, I will explain electrochemical. Now, what is electrolysis itself? Electrolysis, that word, we can break it into two. A part of electro and the other part, which is lysis. So electro means basically electricity, while lysis means breaking down, breakdown. So the word altogether, it means we are breaking something down using electricity. So what are we breaking down? How are we going to do it? What are the processes? What are the materials involved? So to carry out electrolysis, the definition of electrolysis, which means it is a chemical decomposition of substances using a direct current. So it means, number one, we'll be needing direct current, which is electricity, and we're breaking it down. So how are we going to have the setup? So we'll be explaining this electrolysis because we have different types of electrolysis. We have electrolysis of so many substances, and examples are electrolysis of acidified water, We have electrolysis of brine, which is that of sodium chloride. We have that of copper sulfate, and so on and so forth. So from here, it is clear that our substances can either be a salt or an acid. And these substances represent something we call electrolyte. So it means we need materials like, number one, we need electrolyte. Which, like I said, can either be an acid or a salt. Then we need electrodes. Why do we need electrodes? Electrodes are metallic conductors. They will help us transport electricity from our source into the electrolyte. We have the first electrode that is referred to as anode, which is the positive electrode. And we have the second one, which is referred to as cathode, which is the negative electrode. So we also have our current, our source of electricity, which is direct current, is needed, maybe from a battery or something. Then we need the container, which will contain the electrolytic setup. We call it voltmeter. So after all these materials are complete, we have our setup. We have the voltmeter, which is the container that contains everything we need. This is the voltmeter, this is the container. So in the container, we are going to pour our salt, which is sodium chloride, NaCl. But not to forget, electrolysis, it occurs when your electrolyte is in its molten or dissolved state. That means this sodium chloride must be dissolved in water. It must be dissolved in water. So that means we have two substances on ground now. We have our water and we have sodium chloride. So in this particular container, it contains water as it is. We are going to pour sodium chloride in it. So as it is now, sodium chloride will be there dissolved. Now, the next thing is to insert our electrodes. We have our electrodes, which are conductors. This is our positive electrode, and this is the negative electrode. So our positive electrode, like I said, is referred to as anode, and the negative is referred to as cathode. So the next thing is we connect our electrodes to our external DC source, which will be a battery, like I said. Now, immediately this is done, we complete the setup. Three things will happen. Number one, we have dissociation of ions. And we have, secondly, we have migration of ions. And we have the last one, which we refer to as preferential discharge. So let's take this point one after the other. We have already set up we have our electrolytic setup here. We have it here. So we want to know what is going on, after which we have completed the setup. So the first one is dissociation of ions. It means our sodium chloride, which is already present in water, will be dissociated into its ions. Similarly, H2O, water, which dissolves the sodium chloride, will also be dissociated. It means we have two substances now. We have H2O, which will break down, and we have sodium chloride as well, which will also break down. Now, how will the breakdown look like? We'll have sodium chloride breaking down into Na plus and Cl minus. We have H2O breaking down into H plus and OH minus. Now, that means we have two types of ions on ground. The positive ions, and we have the negative ions. Now, like charges repel while unlike charges attract. The negative ions will be attracted to the cathode, Why the positive ions will be attracted to the anode? Opposite charges. So sodium ion and hydrogen ion will move to the cathode, while chloride ion and hydroxyl ion will move to the anode. So that's the first step, second step, which is migration of ions. Ions have already been dissociated, then they now migrate. They migrate to electrodes of opposite charge in such a way that the ones that are negatively charged migrates to the positive electrode, while those that are positively charged migrates to the negative electrode, like that. Now, what happened? The third thing now, which is preferential discharge. So the next thing is preferential discharge. It means these ions, these two ions, chloride ion, hydroxyl ion, sodium ion, and hydrogen ion, they will be discharged preferentially. One of these two will be discharged. One of these two will also be discharged. So how will they be discharged? There are conditions before any of these two, conditions to consider before any of these two will be discharged. There are also conditions to consider before any of these two will be discharged. What are the conditions? We have number one condition. We call it concentration of ions. Concentration of ions. That's the first thing to be considered. Secondly, position in the series, electrochemical series. Position in electrochemical series. And the third point is nature of electrodes. Nature of electrodes. Now, this electrolysis that we are considering, like I said earlier, is electrolysis of brine. Electrolysis of brine, which involves sodium chloride. And this sodium chloride is concentrated. So the concentration of ions will come into play, and other things that will be considered later. Now let's take the cation first. Ions found on the cathode are called cations. Cations are found on the cathode. And the two ions found on the cathode are sodium and hydrogen. So we're going to have sodium ion, Na+, and H+. Which of these two are we going to discharge? Now, if you look at the series on the screen, you will discover that sodium is higher than hydrogen in the series. Hydrogen is below sodium. So therefore, hydrogen will be discharged, while sodium will remain in solution, because sodium is higher than hydrogen. Yes, that's using position in the electrochemical series. Reason why we use position in the electrochemical series is that the concentration of both sodium and hydrogen is the same in this electrolysis. So the next thing to judge who to leave and who to remain is position in the electrochemical series. So sodium is above hydrogen, so hydrogen is going to be discharged. How? We're going to come back to that later. Now, at the anode, what happened at the anode? At the anode, we have anions. On the anode, we have anions. We have both chloride and hydroxyl ion on the anode. So which of these two will be discharged? We have Cl- and we have OH-. Which of these two will be discharged? Now, like I said, that this electrolysis is electrolysis of concentrated sodium chloride. Here, I said it here. We have concentrated sodium chloride. That's what we're considering. So, in electrolysis of concentrated sodium chloride, chlorine is at higher concentration. than OH minus. The concentration of chloride ion is higher than OH minus. And as a matter of fact, when we're using concentration of ions to judge who to leave and who to remain, ions of higher concentration will be discharged, while ions of lower concentration will remain. So it means chloride ion will be discharged, while OH minus remain in solution. So now we have both hydrogen ion and chloride ion to be discharged. So how will they be discharged? Now don't forget, the type of reaction involved in electrolysis is what we call redox reaction. Redox reaction. Redox is from reduction and oxidation. Reduction and oxidation. First, what is reduction and where does it occur? Reduction. We have 5 definitions of reduction and oxidation, but in this part, electrolysis will be using 2. Reduction is gain of electron. Gain of electron, E minus. Same reduction is decrease in oxidation number. Decrease in oxidation. Those are the 2 important definitions of reduction as far as electrolysis is concerned. Gain of electron and decrease in oxidation number. So what about oxidation? Oxidation, just opposite of reduction. It is loss of electron, E minus electron, and it is also increase in oxidation number. Now, we've gotten the definitions of oxidation and reduction. Now, reduction takes place at the cathode. Reduction takes place at the cathode, while oxidation takes place at the anode. Oxidation takes place at the anode. Reduction takes place at the cathode, while oxidation takes place at the anode. Now, this is tell us that hydrogen ion, which is present on the cathode, will undergo reduction. Hydrogen is present on the cathode because it's a cation. It will undergo reduction because that is the reaction that takes place at the cathode. Don't forget, I said reduction is gain of electron and decrease in oxidation number. So this is how hydrogen will be lost. H plus, hydrogen ion, H plus E minus to give H2 gas. This aqueous. Now look at the reaction. You will discover that we have electron here. Any reaction where you have electron at the reactant side, it indicates gain of electron. But when you have electron at the product side, it indicates loss of electron. That's number 1. So it means this is gain of electron, which is also the definition of reduction. So now, another thing is that if you look at reduction again, I said we have 2 definitions for reduction: gain of electron, then decrease in oxidation number. So if you look at the oxidation number of hydrogen in this reaction, hydrogen is coming from +1 to 0 because any molecule in the ground state, like hydrogen gas at the product side, it indicates that the oxidation number is 0. So +1 to 0 is reduction. Reduction in oxidation number or decrease in oxidation number. So this is how hydrogen will be lost. But one thing I want you to take note of is that if you look at the number of atoms, it is not complete. Here we have 1 hydrogen. Here we have 2 hydrogen, H2. So how are we going to balance this? This is very simple. Just put half here at the back. That means half multiplied by 2 is 1. So all hydrogen at the product side is 1 because it is half multiplied by 2, which is just 1. And the number of hydrogen here is also 1. So this is the half equation. Half equation at the anode. Or at the cathode rather. At the cathode. Not anode. At the cathode. This is how hydrogen is liberated. So during electrolysis of brine, point number 1 is that at the cathode, H2 gas is liberated. At the cathode, H2 gas is liberated. That's point 1. Let's now go to the anode. What's going on at the anode? At the anode, we have chloride ion and hydroxyl ion. So how will they be liberated? We have already concluded that chloride ion will be liberated because the concentration of chloride is higher than that of hydroxyl. So the ion with higher concentration will be liberated as one of the conditions we consider during preferential discharge: concentration of ions, position in the electrochemical series, and nature of electrodes. So we have concluded that chloride ion will be discharged. How will it be discharged? Don't forget, chlorine is found at the anode, so it will undergo oxidation at the anode. Oxidation. And don't forget, the two definitions of oxidation is loss of electron and increase in oxidation number. So at the anode now, we're going to have our chloride, Cl minus, to give Cl2 plus E minus. Now you can see we have electron at the product side, and I said earlier that when you have electron at the product side, it indicates loss of electron. So this equation indicates that chlorine is being lost at the anode. And if you check very well, you will discover that chlorine is coming from -1, minus, because it's Cl minus, you can see from minus to 0. From -1 to 0 is increase. Negative to 0 is increase. So it indicates the first definition, which is increase in oxidation number, then loss of electron because we have electron at the product side. But yet the number of chloride is not balanced because here we are having 2 chlorine and here we have 1. So just simply put half at the back. So half multiplied by 2 is 1. So this is aqueous and this is gas. So this is the half equation at the anode. Half equation at anode. So this indicates that in electrolysis of brine, concentrated brine, or electrolysis of concentrated sodium chloride, chlorine gas will be liberated at the anode. So one of the application of or uses of electrolysis of sodium chloride, concentrated sodium chloride, is production of hydrogen, production of chlorine gas. Those are two out of all the application of electrolysis of sodium chloride. So it means we now have sodium ion, Na plus and OH minus left in the solution. So the two are going to form what we call sodium hydroxide, NaOH, sodium hydroxide, at the end of the day. So that's another application of electrolysis of sodium chloride. It will also be used in the production of sodium hydroxide. So 3 things now: production of hydrogen gas, production of chlorine gas, and production of sodium hydroxide. So like I said earlier, that electrolysis is simply when you use electricity to decompose substances. When you use electricity to decompose substances, and all these phenomena, all these mechanisms are going to happen. And the applications of electrolysis, we have one that we refer to as electroplating. We have the one I've earlier mentioned, production of chemicals. Production of chemicals. So chemicals like hydrogen gas, like chlorine gas, and like sodium hydroxide. Now I want to explain the concept of electroplating because it's very important. Before I go there, we have two laws in electrolysis. We have Faraday's first law of electrolysis and Faraday's second law of electrolysis. We'll be using Faraday's first law here now. So Faraday's first law of electrolysis states that the mass of a metal deposited at the cathode during electrolysis is directly proportional to the quantity of electricity passed through it. So mathematically, you can say mass M of a metal deposited at the cathode or dissolved at the anode during electrolysis is directly proportional to the quantity of electricity passed through it. That's mathematically. And we all know that from electric current, Q is equals to IT, where I is current and T is time. So removing this proportionality sign, we can say we have M to be equals to ZIT, where our Z is electrochemical equivalent. Electrochemical equivalent. So these are one of the formulas we use in electrolysis to calculate the mass of a metal deposited when a particular amount of current is passed into the electrolyte for a particular time. And we have another formula that mass divided by molar mass is equals to Q, which is quantity of electricity, divided by NF. This F represents Faraday constant, which is 96,500 coulombs. And this N is number of electron transferred, number of E minus transferred, electron transferred. How are you going to know number of electron transferred? Let's go back. In this reaction of sodium chloride, we have one electron that was gained by hydrogen. Hydrogen gained one electron because at the reactant side is gaining, while chloride lost one electron, you can see. So it means it is just one electron that is transferred between them. So for electrolysis of brine, your N will be 1, your F will be 90,500. Your Q can be calculated from IT, while your mass and molar mass can be input. So you can easily have your calculation done using these two formulas. So another point I want to make is that during electrolysis, the anode reduces in size or reduce in size. Reduce in size, while the cathode increase in size. Cathode increase in size. So it means what you are losing at the anode is what you are gaining at the cathode. Nothing is lost. You lose something at the anode, then you gain something at the cathode. That goes back to the concept of electroplating. Electroplating. So electroplating is when you are coating the surface of a metal with another metal. So if, for instance, now your spoon, you want to coat your spoon, you say this is your spoon. You want to coat the surface of your spoon with gold. You make your spoon the cathode, while you make gold metal the anode. Then you have your setup. You pass current through it like this, and you have your suitable electrolyte in which the two are dipped. So immediately you start the process, the anode, like I said, it will reduce in size, while the cathode will increase in size. So your gold will start flowing from where it is like this and coating the surface of the spoon. And at the end of the day, you have a gold plated spoon. So that is just the concept of electroplating. So I've come to the end of electrolysis. If you have questions, you can drop in the comment section. And in the next video, I'll be explaining the concept of electrochemical cell, which is this. Thanks for watching. Kindly subscribe, like, and share. Thank you.